Good morning, I'm Glenn Chamberlain, and this is the presentation on IMAP and DNS for Professor Green's ISA 4220 Fall of 2017 course. In this presentation, we'll be discussing the listed protocols, which are IMAP, or Internet Message Access Protocol, and DNS, which goes by domain name server, system, and service. We'll have an in-depth discussion over the technical aspects of how both of these protocols work, as well as a discussion on how to safeguard your environments when these protocols are operating. IMAP stands for Internet Message Access Protocol and operates over ports 143 for unencrypted and 993 for encrypted, and is a protocol utilized to manage emails on mail servers and clients' local machines. The emails remain on the mail server where they are centrally stored and managed, but can be manipulated within users' email clients as though they were locally stored on their computer. The changes made within the email clients then sync across any client that the mailbox is configured on. This overcomes many of the limitations and drawbacks of using POP3 in regards to user experience and email management across multiple devices. In the corporate environment, where users often need constant connection to their email across multiple devices, such as Outlook on their work PC, their laptop, their cell phones, etc., this is a necessity. IMAP works by creating a session over port 143 and can be initialized by either the client or the mail server, which is referred to as an asynchronous relationship. The communication between the client and the server transpires over a series of states, with each state allowing different commands. The first state after initiating a client-server connection is not authorized. Not authorized allows for the commands start TLS, authenticate, and login. The start TLS command will initialize TLS negotiation between the client and the server to provide for a secure and validated means for communication between the systems. Authenticate will use SASL, SASL, between the client-server communication to validate the user credentials. SASL stands for Simple Authentication and Security Layer. It provides authentication to connection-based protocols. With SASL, the server will provide a list of authentication mechanisms, such as CRAM MD5, which is a hashing, NTLM, or GSS API, which is used to support Kerberos authentication, and the client will then choose one that is compatible with it. The login command will attempt to authenticate by using a username and password for the user, and is generally not permitted until after the successful configuration of Start TLS. Once authenticated, the next state is reached, which is authenticated. It is in this state that the user is able to create, delete, and manipulate mailboxes, but will be unable to change the contents of those mailboxes. The commands available within this state are create, delete, subscribe, list, lsub, rename, select, examine, and unsubscribe. The subscribe and unsubscribe commands are used in reference to news groups and public folders, which are now available within IMAP. The lsub command lists the mailboxes that the user has subscribed to, while the list command will show all mailboxes currently available for the user to access, and those could also include public folders. If the select, examine, or status command is used, the syntax expects a mailbox name to be used as well, and that will move the session into the selected state. The selected state allows users to manipulate the actual contents of the mailbox with the use of copy, fetch, check, close, expunge, search, store, and the UID commands. The UID, its unique identifier, is used to uniquely identify messages in conjunction with the other commands listed. For example, the copy command can be used with the UID to take multiple messages and append them to another mailbox, or the search command can locate a specific UID within the mailbox. The final state is the logout state and can be reached from any of the previous states at any time. In this state, the connection is being terminated and can be due to the client sending a logout command, simply closing the connection, or the session inactivity time has expired. The inactivity timer, if configured on the server, must be at least 30 minutes, and any command sent to the server during that time from the client will cause the timer to be reset. So it'll be 30 minutes from the last command received. Just as the logout command may be used at any state, the NOOP, N-O-O-P, and capability commands are as well. They can be used at any time. The capability command is used to request a current listing of capabilities that is supported by the server, such as the supported authentication mechanisms. The NOOP command doesn't actually do anything to pull information, but it will always succeed and is generally used to periodically poll for new messages on the server, as well as to reset the inactivity logout timer that we discussed previously. Some hardening steps for IMAP. To prevent emails being sent to the client via plain text, where they could be intercepted and viewed by a malicious third party, they need to be encrypted. This could be accomplished by configuring IMAP to utilize SSL and TLS on the server. This is a simple step that can greatly improve the integrity of the email communication within an organization. On a Windows Exchange server, TLS or SSL is configured either by the GUI in the EMC or the Exchange Management Console. I personally like using the EMC, or by utilizing PowerShell. For more complex tasks, I like to use PowerShell. It seems to succeed more often than not, and once you have the syntax down, it's very easy to manage. If the EMC is used, navigate to the following location. It's going to be server configuration, and then client access. In the work pane, select POP3 and IMAP4, and then select properties under IMAP4. Within the properties window, then select authentication and enter the name of the X.509 certificate that was created when configuring the self-signed certificate that allows for HTTPS communication, or by selecting a purchase certificate from a certificate authority that we've discussed multiple times. You can get those from GoDaddy, for example. They're not too expensive and they usually last for a couple of years. If PowerShell is chosen as the chosen method to use, simply input the commands listed there. It's going to be the set tech IMAP settings space server, your server name. Obviously, what's in italics is going to change dependent upon your environment. So it'll be your server name and the certificate name assigned to your certificate. Within the Linux environment, the configurations files for Dovecoat located at etc dovecoat conf.d/10 tech SSL tech conf must be set to use SSL. By setting the variables under the commented out SSL/TLS support to be required, it will force the client and server to send emails in this encrypted communication. You have three options for that. You have yes, no, and required. Yes will support the TLS SSL communication. No will not support it, and required will force it. Another step you could do is to prevent plain text authentication. Preventing clients from utilizing plain text passwords and usernames will secure the server environment by preventing confidential information from being transmitted unencrypted. If the emails are sent via TLS SSL but the passwords and usernames are transmitted in plain text, it circumvents the security established in other areas of the IMAP configuration. To prevent this plain text transmission on the Linux server, the configuration file that we mentioned earlier must be set to deny plain text authentication. Within the configuration file, the setting disable_plaintext_authority or AUTH needs to be set to yes. Within the Windows environment, navigate pretty much to the same place we were at earlier. It's going to be server configuration, client access. In the work pane, select POP3 and IMAP4, and then select properties under IMAP4. Within the properties window, then select authentication. Within this tab, select secure login and ensure the certificate name, again there, for the X.509 certificate name is correct. Okay, we're going to now discuss DNS. DNS, or Domain Name Service, operates over port 53 and is critical to the operation of the Internet. It's the Internet's equivalent to a phone book in that it matches up series of numbers, usually phone numbers, but in this case IP addresses, to host names. The reason this is necessary is that it's pretty difficult for people to remember the series of numbers to access web addresses, and it's much easier to remember the host name such as Facebook or YouTube. But computers and other devices, such as routers, servers, everything else, require IP addresses to locate. The DNS servers translate those host names or domain names that are easily recalled by people and translates them into IP addresses for the computers and infrastructure to function. These translations are presented as A records and directly match host names to IP addresses. While this is a very important function of DNS, it is far from the only one. There are a myriad of different records contained with DNS for host names. A similar record is a CNAME that matches aliases of the domain to the actual domain. For example, if you want users to be able to access your site, which is at example.mysite.com, with a different name such as EX, short for example.mysite.com, a CNAME record would still take the user to the intended site if configured appropriately in the DNS records. Another type of record, which is very relevant to the presentation for IMAP and SMTP that we've gone over, is MX records, which are critical to email. MX records are utilized by SMTP to route emails to their correct location. If an organization receives emails directly to a hosted on-site Exchange server, then the MX records would point to their statically assigned IP address of their internet-facing email server or their firewall with the appropriate policies configured to route the traffic then to the correct internal server. Most of the clients I personally work with utilize a cloud-based solution for spam filtering called SpamTitan. So their DNS MX records are going to point to the spam filter's hostname, and then within the spam filter, it's then configured to route those emails directly to the organization's mail server. So how does it work? Starting from the end user and moving up is the best way to explain what's going on during a DNS query. The first thing that happens once a user requests a website via hostname is the computer will check its local DNS cache. This is a local store of recently retrieved DNS queries. This minimizes network traffic from constantly running the same searches. If the computer does not have that, if the computer does not have it, then it will then reach out to the DNS server on the network that's configured in the network interface on the computer. You either set it statically or it'll be passed out via DHCP, which will be managed by the DHCP server or another device managing DHCP on the network. This is usually a server, the DNS server is usually a server within the local network that has the DNS role installed or configured on it. But you can also set it up to use public DNS servers. Commonly in troubleshooting, I've used Google servers, DNS servers, which are 8.8.8.8 and 8.8.4.4 to name a few. If these servers that we just discussed, the local DNS servers or the public ones, do not have the records, they will query the root name servers. There are 13 of these root name servers across the globe. They do not have all the records like you might think they would, but they're able to direct you to the servers that do. The root name servers end up looking at the end of the request, such as the .coms, the .orgs, the .govs, .ru if you're in Russia, and direct the query to the top-level domain name server for that specific top-level domain. These servers also won't have the specific information required, but will direct the request to the servers that do. The top-level domain servers will then look at the domain listed in the request, that section between the www and the .com or .org, and then direct the request to the name servers responsible for that domain. These name servers are where all of the DNS records that we discussed earlier are kept. It is here that the A record that translates the host name to the IP address will be found. I just spent about 3 weeks trying to track down where the name server is being described or being notified for one of my clients. Ended up being their registrar when they first purchased the domain was pointing to the wrong name server. So the DNS records that we were altering had no effect. It ended up being in Cloudflare, and it was just a mess. So DNS can affect a lot of things, and it's important to know what your name servers are and have access to them so you can edit them appropriately. So a couple hardening steps to take with DNS. You can limit recursion. Hackers can use recursion to DOS the server, so it's best practice to limit them to administrators because they're enabled by default and they are used to query other DNS servers for a client that is requesting for a name to be completely resolved, and the answer is then sent back to the client. To disable recursion on IIS, you go to the properties on DNS, applicable DNS server, go to the advanced tab, and then select disable recursion checkbox under server options. You can also use the command line by typing that command there. Obviously, you're going to put in your server name. Another important thing that I've encountered working IT is FPF records. They're not necessarily important to protect DNS, but they're a very useful and effective way to prevent mail spoofing on your domain, and it is a DNS record. An SPF record identifies which mail servers are allowed to send email from your domain. It limits the sending of email flagged as your domain from coming only from the IP addresses and domains listed within the SPF records. So it's a very, very strong way to prevent people from using your email address maliciously. So that's my presentation on IMAP and DNS. I look forward to watching everyone else. I've thoroughly enjoyed discussing DNS. It's very interesting to me. I've had many tickets come my way the last couple weeks, so I've had to do a deep dive in it for work. So it's really good timing and it's very interesting to me. Thank you. I hope you enjoyed my presentation.